Hello everyone, welcome back. Here is vanAmsen. Today we are tackling a classic computer science problem, detecting a cycle in a linked list. By the end of this video, you will be a cycle detecting pro. So with two robust solutions, so let's get started. The task is straightforward. So you have a singly linked list, and the challenge is to discover whether the list is linear, meaning it has an end, or if it loops back to itself. So a looping list is what we call a cycle, and its job is to detect if it exists. So, but first, let's clarify some foundational concepts. So, node anatomy. So each node in the list holds an integer value, a next pointer directing us to the subsequent node. So as you can see, we have a node and it points to next node, and we need a cycle detection. So your code should return true if a cycle exists, otherwise false. So as you can see here, we have a cycle because 4 is pointing to 2, and then we have a cycle. And if there is no cycle, so for example, this list with, I don't know, 1, 2, 3 is without cycle. But if 1 points to 2, and for example 2 points to the 1, then we have a loop or a cycle. So and the big question, can we solve this using only constant extra space? So in second approach we can. So now to the first solution. The first approach is what I like to call the memory lane approach. So we are going to remember each node we visit using a hash table, and if we ever revisit a node, that means we are going in circle, literally. So the hash table, or in Python a set, will store a reference to node, and as we traverse the list, we will check if the current node already exists in the hash table. If it does, we have found our cycle. If not, we add it to the set and move on. Let's implement it. So visited nodes will be set, and current node will be head, and while current node, so if current node in visited node, then we return true because it's cycle, and visited node add current node, and current node will be current node next, and return false. Yeah, false, otherwise false. Okay, so this is our implementation. Let's run it to verify all working perfect. We can submit it. So yes, it's working, and our implementation beat 88% with respect to runtime and 14% with respect to memory. And the time complexity here is O(n), since we touch each node just once. And the space complexity is also O(n), because in the worst case, we might have to remember each node we visit. Okay, so now let's clear it up, and we will try to pointer methods, also called as Floyd cycle finding algorithm. So now let's transit to our second method. So we will use two pointers that traverse the list at the different speed. So think of it as a race between a hare and a tortoise. So if they ever met, we know we have a cycle. So sounds intriguing, doesn't it? So both pointers start at the head, and the slow one moves one step at a time, while the fast one goes two steps at a time. And if a cycle exists, the fast pointer will eventually catch up to the slow one. And if it does, the fast pointer will reach the end of the list. So let's implement it. So it's second approach. So slow pointer will be head, and fast pointer will be head as well. Yeah. And while fast pointer and fast pointer next, then slow pointer will be slow pointer next. And fast pointer will be fast pointer next, next. So it's twice faster. And if slow pointer equals fast pointer, then we return true because we have cycle. And otherwise, we return false. As simple as this. So let's run it to verify it's working. So yeah, it's working. Perfect. So complexity analysis. The time complexity of this solution is also O(n), but here is the kicker. The space complexity is just O(1), so it's constant. And that's right, we are using a constant extra space complexity. So let's submit it for unseen test cases. And as you can see, yeah, it's a bit faster with respect to memory. So it's a bit 48%, and here we have 14%. So it's just a couple of megabytes. So 20.8 versus 20.6. And yeah, it should be as fast. So yeah, 79. I think I have even a faster solution previously, but yeah, maybe the test cases are different. So yeah, while rerunning, you can see it sometimes give result of, for example, 99.68% with respect to runtime. But yeah, it's O(n) time complexity and constant space complexity. And there you have it, two different approach and robust methods for cycle detection in linked list. So whether you opt for the hash table or a clever two-pointer approach, so it's really nice approach and also common in coding interviews. And yeah, don't forget the code for other programming languages like Go, C++, Java, and much more. You can find it in the description below, and hit the like button if you learn something new. And don't forget to subscribe for more awesome content and coding adventure and much more, and also machine learning courses. And this isn't just about solving a problem, it's about gaining more understanding about data structure and algorithm. So keep coding, keep practicing, happy coding, and see you next time.